Now that we have seen how to find probabilities using standard normal table, we are going to look at how to standardize a variable x, where x follows normal distribution mu sigma square. So the first thing to do is we subtract the mean mu, and then we divide the standard deviation sigma to obtain z, where z equals x minus mu, divide by sigma. We then have the standardized z. Whatever we have seen so far, let's use all that in a question. Let's see, given a question, how we standardize the variable and how we use table to find probabilities. First question here. The time taken by the milkman to deliver to the high street is normally distributed with mean 12 minutes and standard deviation 2 minutes. You're asked to find the different probabilities. As you can see that this question is based on a normal distribution as specified in the question, and you have also been given the values of the two parameters, which is the mean value and the standard deviation value. So let's see how we answer this question. We start the question by saying let x be the random variable. X is the time in minutes taken to deliver milk to the high street. We have been given the mean mu, which is 12, and we have been given sigma, which is 2. So from sigma we obtain sigma square. So we have 2 to the square, which is 4. We have the distribution. X follows normal 12 and 2 to the square. Now that you have defined the normal distribution, we can find the probabilities. The first part is you're asked to find the probability that he takes longer than 17 minutes. So you need to find the probability of x is greater than 17. We have the random variable x longer than, greater than 17. First step is to standardize. Probability of, so if we are standardizing, x becomes z greater than. So what is the formula for standardization? We take x minus the mu, you divide by the sigma. So we have x, which is 17, this, you minus the mean, which is 12, and then you divide by sigma, which is 2. Now suppose in the question you were given the variance directly, then you would have taken the square root of that variance, but here you have already been given the standard deviation, so you simply divide by 2. You simplify, you have probability of z is greater than 2.5. Now this looks familiar. We have z greater than 2.5. 2.5 is positive. We take 1 minus the phi of 2.5. We use the normal table to get the 2.5, which is the same as 0.9938. So 1 minus this value, we get 0.0062. Second part, you're asked to find the probability that he takes less than 10 minutes. The part B, probability that x is less than 10. We proceed the same way. So we standardize, x becomes z less than 10 minus the mean, which is 12. You divide by the standard deviation, which is 2. We simplify, we have the probability of z is less than minus 1. Now we have a negative value of z here, which means that the minus 1 is on the lower tail. We do a reflection. It is the same as what? Probability of z greater than 1. Now, probability of z greater than 1 is what? 1 minus phi of 1. 1 minus, so phi of 1. From the table, we have 1.0, which is 0.8413. So we have 0.1587. Part C, you're asked to find between 9 and 13. Probability that x lies between 9 and 13. So we're going to standardize each value of x. So we have the probability of z lies between. So we have x here 9. So 9 minus 12 divided by 2. Here we have 13 minus 12 divided by 2. We simplify. We have negative 1.5. So 9 minus 12 over 2, which is minus 1.5, less than z, less than 13 minus 12 over 2, which is 0.5. From our list of important results, if we have a negative value and a positive value z, we use which formula? We take phi of a plus phi of b minus 1. Phi of 1.5 plus phi of 0.5 minus 1. From table, phi of 1.5 is 0.9332 plus phi of 0.5 is 0.6915. You minus 1. Simplify. You have 0.6247.